Greetings of the day, dear students. In this video, we are going to discuss about the regulation of alternator by synchronous impedance method. We will discuss the regulation formula and also what is the procedure to calculate the regulation using the open circuit characteristics and short circuit characteristics of the alternator, and also we will discuss some important points. What are the points we have considered and what are some of the points we have neglected while performing this test. Right now, coming to the regulation of the alternator by synchronous impedance method, it is defined as the rise in the voltage when the full load is removed, and it is to be divided by the rated terminal voltage. So here E0 minus V divided by V into 100 will give you the regulation, percentage regulation of the alternator using synchronous impedance method. Right? Here, while performing this, in order to calculate this regulation, we are supposed to plot open circuit characteristics OCC of the alternator and short circuit characteristics SCC of the alternator. While performing the OCC, we have to plot the graph for the induced voltage, right, with respect to the different field currents. On x-axis you can observe we used to take the field current IF in amps, and on y-axis you are taking the terminal voltage. Slowly you are going to increase the excitation, that is the field current IF. At different values of IF we used to get the different values of induced voltages, and we used to plot the graph for different values of field current and the different values of induced voltages, right, in steps, and we will join all these points and we used to get this shape OCC. Similarly, we used to perform the short circuit test, right, and slowly you will increase the field excitation, right, and you will observe at some particular point of the field current it is going to draw the full rated current of the machine. For example, if it is some 6 amps, okay, up to there you used to proceed. Slowly you used to increase the excitation, and you will indicate the field current, and you will observe at what point of field current you got the rated current of the alternator, and you will join that point. It is a straight line passing through the origin. So this is how you will perform the OCC and short circuit test on the alternator. Once you get these two plots at some particular value of field current, most of the times that field current value we will consider while performing the experiments. At what value of, for example, if the rated current is 6 amps, at what amount of field current you used to get the rated current of the alternator, that field current, if we consider, that gives you the better values, right? So indicate the field current where you got the rated current of the alternator and project it onto the OCC, and slowly project it, that field current value onto the OCC, and it intersects the OCC at some particular point and indicate that point as E1. Now the impedance can be calculated. How it can be calculated? Our impedance ZS will be given by E1 divided by I1. It gives you the value of ZS. Once you know the value of ZS, already we know that the impedance ZS will be equals to the resistance of the armature Ra plus J times XS, right? From this we can easily find out the synchronous impedance or synchronous reactance XS mod ZS is given by root over Ra square plus XS square, right? XS square. Based on that, XS is equal to root over ZS square minus Ra square. Once you know the value of XS, that is the reactance, synchronous reactance, it will be easy to plot this phasor diagram. Now this is the terminal voltage V, right? Now RA indicates the armature resistance. RA indicates the armature resistance. This is the IA RA, and already we have calculated the reactance XS. So I into XS, CD indicates the I into XS. Now E0 value will be equals to the E0 is nothing but the sum of this OB plus E0 square, E0 square will be equals to the OB square plus BD square. But if you observe, OB is nothing but V cos phi plus IRA whole square plus, and BD is nothing but V sin phi plus I into XS whole square. Based on that, we can calculate the value of E0. Once E0 is known, V indicates the rated voltage, okay, which will be there on the nameplate details of the alternator. So once you know the value of E0, the percentage regulation is given by E0 minus V by V into 100. So this is the angle phi between the voltage and current, right? And see here. But here, using this synchronous impedance method, there are some drawbacks. Here, this method is not accurate because ZS found, the value of ZS found using this method will be always more than its normal value value under normal voltage condition, and also due to the saturation effect, it is also not considered here, right? So the value of regulation obtained will always be more than the found from the actual test. That is the reason why this synchronous impedance method is also called as a pessimistic method. Moreover, as we have discussed here, the ZS value practically will not be constant. But here in this test, we have considered it as a constant value. Practically, the value of this ZS will be varying with the level of saturation, right? So here, now this value of saturation, the value will be larger at low saturation levels. Similarly, the value will be high at will be much more at the higher saturation levels. Sorry, the saturation will be low. The value of the impedance will be larger, right? Which will be larger than the actual value at lower saturation levels, right? That is the drawback. And here the value of ZS, okay, which we have calculated, that is obtained from the full load current in the short circuit test. This is also one drawback. The value of ZS is usually taken, that is obtained from the full load current in the short circuit test. So because of that, here the armature reactance XA has not been treated separately. It has been combined along with the leakage reactance. The total reactance X is the sum of XA plus XL. Here we have not separated the armature reactance and the leakage reactance. We have considered the overall reactance. So these are the some of the drawbacks in this method. So one thing is, the whatever the value of regulation you get, it will be actually higher than the actual value. So this method is also called the pessimistic method. Out of this entire discussion, the important point is, some people will consider at some field current IF, but it's a better practice to identify that value of field current where you get the rated current of the machine. At that point of field current, if you project it onto the OCC, you please better consider that value of E1. Of course, some people will consider at some random value of the field current, And for example, if they have considered here at some particular value, any random value of field current, if they project it then this one will be the even value. But this is not a better practice. Better consider the field current from the short circuit test where you get the rated current of the machine. Right? This is one common mistake where most of the students will commit. Right? Yeah, thank you.